All right, so these notes have to do with multiplying and dividing, in quotes, radicals. So the first thing that we're going to talk about, and I think it's the easiest thing to talk about, is this idea of multiplying radicals. Okay, so what we do when we multiply is we multiply the coefficients that are on the outside of the square root, and then we multiply the numbers inside the radicals, so the numbers underneath the square root, and then we simplify the product using our simplification, okay? So, whoa, I did it again. Sorry, I think that's so cool. But let's go ahead and look at this one. We're multiplying. For some reason, my multiplication dot never showed up. So, sad, sad day. So we're going to multiply the numbers that are on the outsides. So right now, there's like an understood 1 in front of those square roots. So understood 1 tells me 1 times 1 is 1. Square root, and then we have 5 times 15, which is 75. Okay, most people would leave this like this, but we're going to go to our y equals, and we're going to 75 divided by x, and we're going to look at our table to find all of our perfect squares. And the one that I see is the square root of 25 times 3. So when we simplify it, we take the square root of 25, which is 5, and then the other number stays put. So there's our final answer, 5 square root 3. Don't remember, okay. Question number 2. Again, my little multiplication dot didn't show up on any of them, so sad day. So we're just going to 14 times 35 is 490. So I automatically see a good square root, but just to be sure, 490 divided by x, and I'm going to look at that table. 2, 5, 70, 49. Okay, so we're going to rewrite this as the square root of 49 times 10. Square root of 49 is 7. The 10 can't be simplified any farther than that, so that's our final answer, 7 square root 10. This one, first thing that people would say when they see this is that we have to do what's in parentheses first because order of operations tells me I have to. However, we actually can't do that because what's in the square root, they're not like radicals. But we can, however, distribute. Okay, so 2 times 3 is 6, so the square root of 6 minus the square root of 10. Neither of these actually can be simplified any farther, so that's my answer. Square root 6 minus square root 10. So that one was pretty easy. That's pretty cool. And then number 4. So same idea, we're just going to distribute. Boop, boop. So 3 times 27 is the square root of 81 minus 3 times 3 is 9, square root of 9. This actually works out pretty well for us because the square root of 81 actually is 9, and the square root of 9 is 3. So 9 minus 3 is 6. So that's pretty cool. That worked out pretty nicely. Okay, so long story short, that is multiplying radicals. The second part of the notes is a little bit more complicated because it has to do with dividing radicals. Okay, and notice that dividing is in quotes because it's not actually called dividing radicals. It's called rationalizing the denominator because no matter what, we absolutely cannot have a square root in the denominator. It's not good. We don't like it. Bad things happen when we keep it there. And so it's just good practice to get it out, okay? But before we do anything, we have to simplify, okay? So we're going to be plugging a lot of things into y equals and looking at our table, see if we can simplify anything first. Then we're going to multiply the numerator and the denominator by whatever square root is in the denominator. So an example of this, I'm going to zoom in here real quick, is if the denominator is the square root of 2, I multiply the top and the bottom by the square root of 2. Y'all, square root of 2 times the square root of 2 is just 2. Okay? When we multiply things that are the same under the square roots kind of cancel each other out, and we're left with whatever number's there. It's different when we're multiplying things that have different square roots, so like this 2 and this 6, because then we're stuck with the square root of 12, which is 2 square root 3. Okay, simplified. Okay, because if we multiply the numerator and the denominator by whatever is in the denominator, this is what's going to happen. Okay, we should be able to cancel out the square roots and be left with whatever's down in the denominator. Okay, after we do that, we simplify the numerator, and then we divide the coefficients on top by the denominator if it's possible. Okay, I know that seems a little confusing, so let me just do a bunch of examples. And just like I said before in the previous video, I have never done these problems before, so these are all new to me, so I just wanted you to know that. So if I do a lot of mistakes, now you know why. Okay? So here's our first example, square root of 23. Or square root of 21 divided by the square root of 3. So the first thing I'm going to do is see if I can simplify 21 divided by x. I can't simplify 3. That's about as good as it gets. 3 and 7 are the only ones. Okay, so I can't really simplify any farther. Okay, but I know the next step is to multiply the numerator and the denominator by the square root of 3. Okay, so when I do that, if I look and focus on the denominator itself, the square root of 3 times the square root of 3 is just 3. And if you don't believe me, you can plug it into your calculator. But I multiply the top, square root of 21 times 3 is the square root of 63. From here, I'm going to see if I can go to y equals and see if there's any perfect squares that make 63, and there are. Okay, so we're going to rewrite, the denominator stays the same, we're going to rewrite the square root of 63 as the perfect square 9 times 7. Okay, when we take the square root of 9, we get 3 square root 7 divided by 3. Now the last step says to simplify by dividing the coefficient on top by whatever's on the bottom, if possible. In this case, we lucked out because the 3 on the top and the 3 on the bottom completely cancel out, so I'm left with the square root of 7. Which I know some people are probably like, well, miss, you could have just taken 21 divided by 3 and gotten the square root of 7. You're right, we could have done it that way, but we don't want to, okay, because that's not going to work every single time, okay? So let's go ahead. Let's look at this one. Okay, so first thing I'm going to try and do is simplify the square root of 40. When I look at the square root of 40, the first perfect square I see is 4, so we're going to rewrite this. 15 square root of 4 times 5, or times 10. Is that the only one that goes in there? That can't be the only one. Looks like it is. Okay. Divided by 5 square root 5. So we're going to go ahead and take the square root of 4, which is 2, and 2 times 15 is 30. 30 square root 10 divided by 5 square root 5. Okay, now I know that some people are going to rush and say, well, 30 divided by 5 is 6. You're not wrong. However, we need to get the square root of 5 out of the denominator first. Okay, so we're going to multiply the top by square root 5 and the bottom by square root 5. Okay, so when we do that, we end up with something kind of special. All right, the square root of 5 times the square root of 5 is just 5. However, I have this 5 hanging out over here too. So if I were to type this into the calculator, 5 square root 5 times the square root of 5, I actually end up with 25 on the bottom. Okay? When I multiply the top, I still have 30, but now I have the square root of 50. Because remember, when we multiply radicals, we multiply the numbers on the inside. Okay, 10 times 5 gives me 50. So we're going to simplify this one all over again. Okay, so I know that 50, when I plug that in and look at the table, a square root is 25. Okay, so we end up, we end up with 30 square root 25 times 2 divided by 25. Okay, so when we take the square root of 25, it's 5, but 5 times 30 is 150. So we have a 150 square root 2 divided by 25. So now we're going to see if I can simplify that 150 and that 25. So 150 divided by 25 gives me 6. So I end up with 6 square root 2. Okay? So let's go ahead and look at C. First steps first. Let's go ahead. We can simplify first, but let's see what happens if we don't. Okay? Let's just not simplify and see what happens. Let's multiply the top and the bottom by the square root of 8. Okay, so the top, I'm going to end up with 36 times the square root. 160 times 8 is 1,280 divided by 3 square root 8 times the square root of 8 gives me 24. Okay, so now we can use the rest of our time to focus on simplifying this 1,280. So this will be fun. I don't know if you figured out the sarcasm there, because that's a really big number. Oh, that was coincidence. So I'm scrolling, starting with, 2, and 640 is there. That's great. 320, 160. 25 is a perfect square, but it doesn't go in evenly. 20 is a perfect square. 64 is a perfect square. But I think our number is going to be greater than 64. And y'all, I'm pressing the down arrow key on my table, and we're just going to see if we can find a number bigger than 64 to go into this number and make it look pretty. 81 doesn't, 80 does. So let's see. After 81, does 100, not evenly. 11 squared is 121. That doesn't do it. What about 144? What about... Okay, so let's see. Let's break it down, because the first thing that I noticed, the first number I should say that I noticed that went in there pretty evenly was 64. And that's a perfect square. So we're going to go ahead. Wow, why do I keep doing that? We're going to rewrite the square root of 1,280 as the square root of 64 times 20 divided by 24. Okay, so we're going to take the square root of 64, which is 8. 36 times 8 gives me 288. Square root 20 divided by 24. And I hate to break it to you, but 20 can be broken down into something smaller. So we're going to rewrite 20 as the square root of 4 times 5 divided by 24. Okay, so the square root of 4 is 2. 288 times 2 gives me 576. Square root of 5. Oops. Square root of 5 divided by 24. So let's see if I can simplify this 576 and 24. I can. 576 divided by 24 is 24 square root 5. That's my final answer.